Hello, my name is Troy Handlovic, and I would like to start this talk by thanking the UTA College of Science for organizing this opportunity for me to give some insights into my recent research. Today, I will be discussing a collaborative project between the McDonnell, McFarland, and Armstrong groups in the Department of Chemistry and Biochemistry. The goal of this project was to provide an efficient and green separation technique to analyze and eventually purify enantiomers, ruthenium, and osmium octahedral polypyridyl complexes. To better view my poster, I'm going to zoom in on the areas being discussed and emphasize what I think is important in each section over the next few minutes. For a quick introduction to the project, sub/supercritical fluid chromatography, or SFC for short, is a separation technique that uses a supercritical fluid as the major portion of the mobile phase. This replaces the use of toxic solvents and allows for more efficient mass transfer kinetics compared to liquid chromatography. Typically, the supercritical fluid used is carbon dioxide, which has a polarity similar to liquid pentane, making it not suitable for the analysis of polar or ionizable analytes alone. To address this, research has been done on the use of organic solvents and ionic additives that can be mixed with CO2 to provide a modified mobile phase capable of analyzing ionizable or polar analytes. Historical examples have been shown in the literature for the chiral and achiral SFC analysis of ionizable compounds, but these papers have some major mistakes in them that were later unveiled. Recently, a study on the SFC separation of inorganic ions was published, but to date, there's been no chiral SFC analysis of inorganic metal complexes. We sought to apply the benefits of SFC to enantiomerically resolve a class of octahedral bidentate metal complexes that contain delta and lambda isomers as shown in Figure 1. Before I discuss the relevance of these compounds being analyzed, I would like to bring to attention the instrumentation and column chemistry that makes this study possible. In the top picture is the JASCO semi-prep SFC system that is used for all separations in this study. This system contains two pumps, one for the organic modifier and one for the liquid CO2. The two pumps are plumbed into a stainless steel mixing chamber, then a column oven, autosampler, UV detector, and finally a back pressure regulator. On the bottom, we see a drawing of the cyclopropane stationary phase functionalized with R-naphthyl ethyl groups synthesized by AZIP LLC. This study is the first application of this stationary phase bonded to a 2.7 micron superficially porous particle, which is really interesting since these particles have been proven to provide very highly efficient separations. Here, we see 20 ruthenium or osmium polypyridyl complexes that were analyzed in this study. These complexes have multiple biological functions, and some serve as potential photosensitizers for the photodynamic therapy of cancer. The FDA requires that potential drugs be tested as individual enantiomers, so it is important to develop analytical and preparatory methods to separate and optically analyze chiral molecules like these. Next, I will display some of my results. I do not have time to discuss these in details right now, but I will be happy to answer any questions via the chat function of the online portion of this event or in person. I will state what each figure shows us, starting with Figure 2, where the addition of water into the modifier is shown to greatly reduce the retention of the compounds as well as increase the separation efficiency. Figure 3 shows the representative chromatograms for all compounds except for compound 8, which is currently being worked on to improve its chiral recognition. Figure 4 shows the effect of blending acetonitrile methanol in the organic modifier, which is something that's not very common for SFC. And Figure 5 shows mass transfer kinetic plots that indicate the high efficiency of these separations. Figure 6 shows the effect of complex conjugation on enantioselectivity. I will finish my results by showing some sub-minute ultrafast separations. This is something that I'm very proud of in this project, as these separations are extremely green and allow for high throughput. To conclude, this project shows the first chiral ionic SFC separation used in a quaternary optimized mobile phase to baseline separate 15 out of the 20 complexes studied. This is the promising first application of cyclopropane 6 with naphthyl groups on SPP particles. Ultrafast separations were shown for 4 compounds, and the future work will involve resolving the remaining complexes and then developing a prep scale SFC separation for similar compounds. I hope to see you at the conference to better explain this work and answer your questions. Feel free to reach out to me to discuss this project. Thank you for your time.